Hi, guys. Hello. All right. I think you can hear me. Looks like the microphone thing's going on. You guys all have an exam tomorrow. This is the actual exam 8. My other one was exam 7. So we're here. One of the things I wanted to talk about before we get started are these radical problems. So I know that not every teacher taught all of these types of problems, and that's okay. So just for the record, we all met today and we kind of modified some of the tests based on what we got to because everybody lost a day on Friday because of the fires. So if I'm doing something here and you're like, we did not go over that, not a big deal. If you're in my class, this is all fair game because I made a review sheet based on what I know I went over. So I'm going to go over it. But again, if you're like, my teacher did not teach us how to add and subtract radicals, no problem. If you didn't learn how to multiply radicals, no problem. Your teacher will modify the test for these parts based on what they did teach. All right, let's get started. So I like to break down radicals by using a factor tree. So what I do is I kind of try to come up with whatever factors of 24 I can think of. And it doesn't matter. You're going to get the same answer regardless of how you start. It's just a matter of what you come up with first. So for me, I'm going to come up with 6 and 4. If you came up with 8 and 3, 12 and 2, it doesn't matter. All your answers are going to be the same. And then I can break down 4 again to 2 and 2. And I can break down 6 to 3 and 2. Now what I'm looking for are pairs. And for every pair I get to pull them out of the radical. Everything else is stuck inside the radical. So the only thing I have a pair of are a pair of 2s. So this guy gets to come out. And then this guy right here, this 3 and this 2, I don't have a pair of them. They're stuck inside. So anything that's stuck inside, you're going to multiply together. These 2 get to come out. Remember, you need 2 to get out. So I'm going to have 2 rad 6. 2 comes out. These guys are left inside. All right, let's do this one. Whatever I take out, I'm going to multiply by this 6 because this 6 is just chilling here. So anything that I come up with, I'm going to multiply there. So again, the quicker you come up with your perfect squares, the easier this kind of stuff is. So I know most people will not go 16 and 2. That would be the easiest way to do it because you got a perfect square, but I think most of you guys are going to come up with 8 and 4. It's not going to make a difference on how you do this, just that you break it down and you take out each pair. All right, so for this guy right here, I've got a pair of 2s. I've got another pair of 2s. And then I've got 1, 2 stuck inside. So I'm going to take 1, 2 out. I'm going to take the second 2 out. And then with these guys all right here, I'm going to multiply them all together. So it's 6 times 2 times 2. So 6 times 2 is 12. 12 times 2 is 24. I have 24 on the outside, and on the inside, that guy's still left over. So that's 2. Right here. In order to add and subtract, you need to have a common radical. Okay? So make sure you have a common radical. If these 2 are not the same, you can't add them. Think of this like adding negative 9x plus 10x. Okay? We couldn't add these together if this one was y or if you guys had different variables here. So you need to have a common radical. So kind of think of it like this. All right? Once you have a common radical, you're good to go. I have negative 9. I have positive 10. That's a positive 1 left over, rad 15. It's just combining like terms when you add. So right here is your answer for that. You don't need to put the 1 here. This 1 here, I like Mr. Nakauchi. Mr. Nakauchi always calls this the ghost one. So when he calls this the ghost one, if it's there, it's cool. If it's not, it means the same thing. It's a 1 that doesn't change the value of the equation. So this is rad 15. If you need the 1 there, totally fine. It's whatever you choose. All right, go in here. If you look here, we don't have a common radical. So you need to reduce this to get a common radical. If when you reduce it, you don't get a common radical, then it's all good. And you can just, that's as simple as it's going to get. So we're here. Let's break that guy down. We've got 9 and 3, 3 and 3. I've got one pair of 3s. I've got this guy left here inside. He's going to come out. So 3 times 3 is 9. So I'm going to leave this guy the same. He's 2 rad 3 plus 9 rad 3. Now I'm here. I have a common radical. So I can just add these numbers together. So this guy right here is 11 rad 3. For all of your exam, you are going to have, let me zoom in. Zoom. Let's see if that works. Okay, for your exam, you're going to leave everything in simplest radical form. You're not converting anything to decimals. This is only going to be simplest radical form. So I can't break down 3 any further. Up here, like this one, I can't break down 6 any further. That guy's done. All right, let's try this guy right here. Adding again. Let me zoom in again. Let me see if that works a little bit better for you. Okay. More zoom. Okay. You should be looking at this on your paper, silly, so you can do it with me. You don't get better at math by watching me do it. All right. I have a 2 and an 8. Not a common radical. Got to break this guy down. 4 and 2. 2 and 2. This guy's here. Got a pair. That guy's stuck inside. Anytime we bring something out, we multiply. You can see the bacteria on the paper now. You're a classic. At least it's funny at night. All right, so 3 times 2 is 6. I have 6 rad 2 minus 3 rad 2. There you go with your common radical. 6 minus 3 is 3. So your answer is 3 rad 2. Okay, you're just looking for a common radical. All right, let's get into these. Multiplying radicals. For these, you multiply the outside, multiply the inside. Okay, outside of these, again, this is what we were calling the ghost ones. They're there. They don't change the value of anything. Multiplying the outside is still 1. Multiplying the inside is rad 36. 6 times 6 is 36. You cannot leave your answer like that. Okay? Now, everybody, I hope, knows that the square root of 36 is 6. That is as simplified as it's going to get. If you didn't see it, break it down. Okay? You got it by multiplying, so you know your factors are 6 and 6. You already have a pair of them. They get to come out, and you're left with nothing else inside. It's just rad 6. Even if you did it this way, rad 36 right here, even if you went 9 and 4, 3 and 3, 2 and 2, you have 1 pair of 2s, 1 pair of 3s. They get to come out. 3 times 2 is 6. Nothing's left on the inside. All right, so even if you don't right away see that it's 36, or the square root of 36 is 6, break it down, you can get it anyway. If you didn't see it here, like, oh, I have 6 and 6. Oh, it's a perfect square. 3 and 2, 3 and 2. You have a pair of 2s, a pair of 3s. You're still getting 6 no matter what. All right, multiplying this. We're here. 5 times 10 gets me the square root of 50. All right, let's break down 50. All right, I think a lot of you guys would go 25 and 2. That's fair. Again, it doesn't matter. You can go 10 and 5. You're just going to be breaking them down. And I'm going to show you that I'm going to get the same answer regardless of which way I go. So if I did square root of 50, if I did 25 and 2, way easier because I have my perfect square right there. Good for me. I know that the square root of 25 is 5. If you don't know that the square root of 25 is 5, we'll break it down all the way. You have a pair of 5s. That guy comes out. That guy's stuck inside. It's 5 rad 2. If you did it this way, if you did 10 and 5, okay, you have 2, 5, and 5. You have a pair of 5s. That guy's out. This guy's stuck inside. Your answer is 5 rad 2. Okay, so regardless of your factors, there you go. All right, let's try this guy right here. Multiply the outside, multiply the inside. -4 times 1 is -4. 15 times 3 is 45. And then break it down. All right, however you want. I'm going to go 9 and 5, 3 and 3. I have a pair of 3s. He comes out. This guy's stuck right there. So my answer is going to be -12 rad 5. Last one. Multiply the outside, multiply the inside. 3 rad 72. Break down 72. 9 and 8, 3 and 3, 4 and 2. All the way down as far as you can go. I've got a pair of 3s, a pair of 2s. That guy is solo, can't do anything. A 3 is going to come out, a 2 is going to come out. So right here, I'm going to have another 3 and another 2. And again, when you have all these guys outside, you multiply. So 3 times 3 times 2. That gives me 9 times 2, which is 18. This guy's stuck. Rad 2. There's your answer. All right, again, if your teacher did not teach you how to do all different types of these, I know everybody got to like this type of let's go. Since I'm zoomed in. I know everybody got to like this type of radical. Okay? So this is fair game. I know not all the teachers got to the adding of them, and that's okay. So when you get to the radical section on your exam tomorrow, it will only look like the ones that you've gone over in class, right? If you're in my class, this is all fair game for you guys again. Okay, down here. Is it a right triangle, yes or no? All right. In order for it to be a right triangle, we're going to use the Pythagorean theorem. That's a squared plus b squared equals c squared, where a is a leg, b is a leg, it doesn't matter which one, and c is your hypotenuse. Right? Something you need to know, when you're given a series of these numbers, the biggest number is always the hypotenuse, right? Remember that. Largest number is the hypotenuse. So these are all in nice little order for you because it's 3, 4, 5. 5 is the largest, 7, 9, 11. 11 is the largest. Do not get into that trick tomorrow on the exam. If this was written 5, 3, 4, 5 is still the biggest number out of this trio. That guy's your hypotenuse, regardless of where he falls here. So again, order doesn't matter. The biggest one is always your hypotenuse. Don't forget that for tomorrow's test. All right, so how do we know it's a right triangle? We know it's a right triangle when we plug them in and this equation becomes true. So I'm going to use this one right here. I have 3 squared plus 4 squared equals 5 squared. Remember, this is not 3 times 2. This is 3 times 3. So largest or first number? No, it doesn't matter. It's always the largest regardless of the order. Okay? The hypotenuse is your largest. It's always your C. So the largest is always your hypotenuse. Your C always has to be the hypotenuse. So let's go. That's 9 plus 16 equals 25. 25 equals 25. Yes, it does. That's a check. 25 equals 25. The left side equals the right side. This guy right here is a right triangle. So right triangle. Let's try 7, 9, and 11. This guy right here is my hypotenuse. 11's the biggest number, right? So he has to be my hypotenuse. It doesn't matter, again, the order does not matter. The biggest number has to be the hypotenuse, regardless of the order that these are in. So I'm going to go 7 squared plus 9 squared plus 11 squared. 49 plus 81 equals 121. Just so you guys know, everything up to 12 squared is fair game without a calculator. Okay, so let's add these up. I've got 49 here. Let's 10, carry 1, that's 12. 130 equals 121. No, it does not. That doesn't work. So this guy right here, not a right triangle. Not going to be a right triangle. Let me put out another sheet of paper so I can show you guys these last two. Again, remember, you're just using the Pythagorean theorem, something that you guys are all familiar with. So let's do 5, 6, and 8. I'm going to put this here. We've got 5, 6, and 8. Again, we're using a squared plus b squared equals c squared. This guy right here is my hypotenuse. Not because of where he's located, but because he is the largest number. All right? These guys right here, it doesn't matter which way I do a and b. I can go 6 squared plus 5 squared equals 8 squared. I've got 36 plus 25 equals 64. If I add 36 to 25, I've got 61 equals 64. No, it doesn't. So this guy right here, not a right triangle. All right, let's do the last one. We've got 9, 12, and 15. 9, 12, 15. All right, your life is going to be a lot easier if you recognize a Pythagorean triple. Okay, there are 3 or 4 that you're going to see consistently. Okay, one of them is 3, 4, 5. If you see some variation of the 3, 4, 5, you're going to have to start identifying that in an easy way. So I'm going to show you guys how to do this one the long way, but then I'm going to show you how to make it so that it's a little bit easier for you. So again, 15, that's my C. Why? Because it's the largest number. I've got 9 squared plus 12 squared equals 15 squared. When you're there, you've got 81 plus 144 equals 225. Okay. If I add 81 to 144, I get 5, 12, 225 equals 225. Yes, it does. Okay. That guy is a Pythagorean triple. So this guy right here, right triangle. All right. No, that's not 9 plus 12 equals 15. All right. If they don't give you a B or a C or an A or B or C, okay. So for something like this, when they're asking you if it's a triangle, you're always going to see it in a set of 3. Okay. So when they're asking you, is it a right triangle? Yes or no? You're always going to be given 3 numbers. Okay. You're not going to have to find the third number. Okay. I'll show you guys on the next page when we get into actually finding the triangles or using the triangles, what they're talking about with that. Okay. So back to this real quick, just like a little side note. Okay. Do you guys see how, I'm going to turn the page here so you guys can see it. Do you guys see any correlation between 3, 4, 5, and 9, 12, 15? Okay. If you see the, well, it'd be great if you could see it at all. There you go. So do you see the correlation between here, here, and here? Right. If you don't right away, this becomes a lot of work. Think about it. If you get huge numbers like this, at some point, like a little light should go off in your head that says Pythagorean triple. Okay. You guys can see I multiplied all of these by 3. So if you know that 3, 4, 5 always makes a right triangle, any variation on a 3, 4, 5 is also going to make a right triangle. All right. So when we have a 3, 4, 5, that's also good for, let me do that. Okay, 3, 4, 5. There's your 3, 4, 5 triangle, right triangle. It's also good for 30, 40, 50. You guys see I just multiplied each of those, right? It's good for 300, 400, 500. It's good for 3,000, 4,000, 5,000. It's good for any variation. Okay, you still don't understand how I got 15? Because that was the problem. The problem was 9, 12, 15. 9, 12, 15. That's where I got 15. All right, so what I did when I did the problem is I just plugged in. Okay, remember 15 is my largest number, so it's my hypotenuse. I didn't just pull 15 out of nowhere. 15 was the problem. Okay, second page. Solve for missing sides. Couple things for this. All right, things you need to know before we even get started. How are you going to solve for these different sides? You're going to have 3 choices on how to do this. So you just found what the roots were and added them? Yeah, or I did it the long way. I just squared them all and did the Pythagorean theorem. Okay, so how to find sides of a triangle, of a right triangle. Your choices are using the Pythagorean theorem, okay, using the 45, 45, 90 triangle, or the 30, 60, 90 triangle. All right, those are going to be your 3 choices on how to do this. If you're only given one number, like on A or on C or D, okay, when you're only given one number, that little light in your head has to go off saying, is this 45, 45, 90, or is it 30, 60, 90? Okay, because you're not going to be able to use the Pythagorean theorem without a couple of numbers or them figuring out a way to get another side. The other thing you need to understand, there are multiple ways for me to identify a 45, 45, 90 triangle. I can mark these the same to make it isosceles, because if these are the same, then these guys are the same. If you look at letter F down here, these 2 are going to be the same because these angles are the same. These are 45, 45, 90 triangles. And 45, 45, 90 triangles are always going to follow the same pattern. Okay? That pattern is going to be X, X, X rad 2. Okay? It's going to be X, X, X rad 2. So you've got your sides. So that's a leg, leg, hypotenuse. Leg, leg, hypotenuse. If this is your hypotenuse, they've given you the hypotenuse. How do I know it's a hypotenuse? Because it's directly across from the right angle. If this is 3 rad 2, and this is my pattern, X, X, X rad 2, these guys right here are 3 and 3. These require no math. All right, this is straight up being able to identify a type of triangle. All right. If it's an isosceles triangle with the right angle, it's an isosceles right angle. These have to be 45 and 45. I hope that's what you guys see, because when you add up the total is going to be 180. That's why we're getting these. I'm not just making up these numbers and calling them 45, 45, 90 triangles. They're actually a 45-degree angle, a 45-degree angle, and a 90-degree angle to make up the 180 degrees. All right. So when you see this, and there's only one number, okay, and you need to find 2 sides, or there's some kind of marking to mark it isosceles, then just think to yourself, 45, 45, 90. So here, look at F. I'm going to do this 45, 45, 90 right here. If this is 7, this guy's 7, this guy is 7 rad 2. Again, no math, 45, 45, 90 triangle. These 2 sides are congruent. The opposite side is always that number, rad 2. All right, if you didn't know that, okay, the Pythagorean theorem works for this. If I give you 7 and 7, and use the Pythagorean theorem, you would get that answer. All right, this is just a quick, easy, like cheat way to do it by not cheating, just memorizing a little trick. All right, let's go back up to B. This guy right here. 2, 3, and x. All right. The only way you're going to be able to find this, it's not a 45, 45, 90. The way, because I know that because these two legs are not congruent. All right. I'm giving you two sides. Use the Pythagorean theorem. Okay. Use the Pythagorean theorem. 2 squared plus 3 squared equals x squared, which is technically our c squared, right? 4 plus 9 equals x squared. 13 equals x squared. Now I'm here. I can't leave it like this. I need to take the square root of both sides. So once you're here, take the square root of both sides. And that's going to give me x equals the square root of 13. That's my answer. This guy right here is rad 13. Again, all your answers left in radical form. You're not putting them in decimal form. All right, this guy right here, 30, 60, 90 triangle. Okay, 30, 60, 90 triangle. Why do I know it's a 30, 60, 90 triangle? Okay, I know it's a 30, 60, 90 triangle because that's 90, that's 60. So this guy right here has to be 30 because I know they have to equal 180. The rules on the 30, 60, 90 triangle, all right? The side opposite the 30 is your x. The hypotenuse, which is the side opposite the 90-degree angle, is 2x. And opposite the 60-degree angle is x rad 3. Okay? For 30, 60, 90, you have to cut the long leg in half to get the answer. It depends on what side you're given. Okay? So it's always the 30 is the smallest side, the 90 is the biggest side, and the 60 is always going to have the radical in it. All right. So what side am I given here? I'm given the side opposite the 30. Here's this side. It's opposite the 30. So my 30 is x. Okay? To find opposite the 90, it's 2 times that. So 2 times 8 is going to get me 16 for the hypotenuse. Opposite the 60 is always whatever you have at 30. This one is 8 rad 3. Again, for these kind of things, minimal math. All right, you have to know this part right here. If you're only given one side, there's no other way to do this than to know the rule on a 30, 60, 90 triangle. That's the point of this exam, is to memorize these rules for the 45, 45, 90, and the 30, 60, 90. Okay, let's look at this guy right here. This is D. Let me zoom in for you here on this guy. Okay, so going off of our same rules here. Opposite the 30 is your x. Opposite the 90 is your 2x. Opposite the 60 is your x rad 3. Okay, what am I given? I'm given opposite the 90. This is the one I'm given. I'm given this guy right here. Okay, and I know that's 2 times x. So opposite the 30, this guy down here is half of the hypotenuse. Opposite the 30 is half the hypotenuse. Half of 18 is 9. Opposite the 60 is whatever opposite the 30 is plus a rad 3. So this guy right here is 9 rad 3. When you're here, you have to memorize the rule because that's just the rule. Okay? You know, again, memorize the rule. Okay, on a 30, 60, 90 triangle. Here's a 30, right? Here's your 30-degree angle, which makes this guy your 60-degree angle. Okay? Opposite the 30-degree angle is always your smallest side. All right? We're just going to call that side X. I just labeled them A and B here so you guys can fill in the blanks. Your goal is to find the sides. You're solving for the missing sides. That's what you're looking for. You're looking for this length and this length, depending on what's given. So for this one, I gave you opposite the 90, right? I gave you 18. I gave you this guy right here. How did I get that? This number is double this one. The hypotenuse is always double this guy. So this guy is 9 because it's half, right? The hypotenuse is double this guy. Opposite the 60 is always whatever you found for your x. So like this guy's x, right? X equals 9. This guy is 2x. This guy is x rad 3. Because he's opposite the 60. So he's 9 rad 3. Okay, all we're looking for is finding sides. I can do more of these. Let's just keep going through. For this one, you're given two numbers, Pythagorean theorem. Unless you can see it's a Pythagorean triple right away, we're looking for that side right there. Okay? 1 squared plus 2 squared equals x squared, or in this case, c squared. We're just changing up the variables. It's the same problems over and over and over again. 1 plus 4 equals x squared. 5 equals x squared. Take the square root. X equals the square root of 5. So this side right there is the square root of 5. All right. And F I already did. It's a 45, 45, 90 triangle. So x, x, x rad 2. All right, these two are the same. This guy's whatever that number is, rad 2. What if you know the square root? You know the square root of 5? The square root of 5 you can't break down. You're going to leave your answer like that. Okay? You can estimate the square root of 5 in a decimal form, but for your exam, you're going to leave everything in radical form. Yeah, okay, so like, let's say here you got the square root of 25. That's not the simplest form. So if your answer somehow got you here to the square root of 25, like that, wrong way, sorry. You would have to simplify that. That's not simplified. You can break that down, okay? That is a simplified answer for that. So make sure that if you can break down your radical, you break it down. If you can't, you leave it. So this guy right here, he's the square root of 5. That's the answer. It stays that way. Okay, there's a problem like this on your test. Will it be wrong if we don't? It's wrong if you do not reduce your square root. All right, you're going to lose points for not reducing your radicals. Your radicals have to be reduced. So if you give me this answer and not this answer, that's not correct. If you leave something like rad 8, that's not correct. You need to break that down. Okay, you have to break down your radicals. That guy comes out, that guy's stuck in. It's 2 rad 2. So this will not get you full credit. This is going to get you full credit. You have to break them down. Okay. Find the height of this triangle. Okay. It's actually equilateral. It's not even isosceles, but whatever. So for here, this is 6 and this is 6. You guys have right angles. Okay. Pythagorean theorem. You guys see right here? Okay. They want the height. They want this guy right here. This guy is 6 and this guy is 12. It's just Pythagorean theorem. So we have our hypotenuse. This is our C, right? So we have 6 squared plus h squared equals 12 squared. Move that way. 36 plus h squared equals 144. Subtract 36 to both sides. H squared is equal to 108. And here's where your question comes in. Once I take the square root of both sides, I have h is equal to the square root of 108. I cannot leave my answer like that. Hold on. Sorry. If it can be broken down. If this is the simplest it gets, we're good to go. But I know I can break down 108. I'm going to break it down right here so we have more space. All right, I can't come up with a big number off the top of my head that goes into 108, but I know 2 does because it's even. So I'm going to go 2 and 54. Now that I got 54, I can break that one down into 6 and 9. If you didn't see 6 and 9 and you went 2 and something else, by all means, break it down however you can see it. I've got 2 and 3 and 3 and 3. All right, what do you have a pair of? I've got a pair of 3s right here. I've got a pair of 2s right here. And I've got this guy stuck inside by himself. I've got a 2 and a 3 coming out. So a 2 and a 3 are out, which gives me 6. This guy's stuck inside. Your answer is 6, rad 3. All right. How about 9 times 12? Why would I do 9 times 12? I'm not sure why it would be 9 times 12. You're talking about if you wanted to break this one down 9 times 12? Oh, yeah. Okay, so if you wanted to do this 108 and go 9 times 12, totally fine. Okay, break it down. Hold on, I'm going to run out of space. I'm going to do it here for you. Okay, again, it doesn't matter which factors you use to break it down. You're going to be good no matter what. So here's the square root of 108. All right, you wanted to do 9 and 12. Not a problem. 3 and 3, 4 and 3, 2 and 2. You have a pair of 3s, a pair of 2s. This guy's still stuck inside. Multiply that together, you got 6 rad 3. Either way, I got the same answer. I did 2 and 54, I got 6 rad 3. You did 12 and 9, you got 6 rad 3. If it was 3 root 12, no, you cannot leave it as 3. That's not completely simplified. Okay? You're talking about leaving it here, like 3 rad 12, because you can still break down 12. Okay? That's how I can do that. So when I break that down, that guy comes out, and I still get 6 rad 3. Okay? You took it one step further. You broke it down a little bit up here, but it's not complete. That's not completely simplified because you can still break down 12. Okay? This guy right here, 6 rad 3, is completely simplified. All right? If you did it like this, I know where you're going with this. I see where you're at. You're all good. Okay? You're still getting partial credit for these problems. You went here and you went 9 and 12. Okay? It doesn't have to be a perfect square. You're still reducing. You took your perfect square out here. So you got 3 rad 12. Okay? That's fine. That's not completely reduced. Because you still have another perfect square right here. 4 is a perfect square. So that guy's got to come out too. All right? You have 6 rad 3. All roads lead to Rome. They're all 6 rad 3. All right. How did I get what? How did I break down 108? Is that what you want to know? All right, let's go back to the original problem, which was this. Okay? I just moved it to another sheet of paper because I needed to take the square root of 108 right over, wrong way, that way, right here. And I ran out of room. When you break down this, it doesn't matter which numbers you do as long as you go to the most simple form. So you can't break down any more. And so what I showed you was I broke it down using 2 and 54, then 6 and 9, and then broke it down even more. All right. What Paulina asked is if she used 12 and 9, does that work too? And the answer is yes, it does. But you can't leave it as 3 rad 12 because 12 has a perfect square in it also. Okay. So the goal of the answer is right here, 6 rad 3. You're finding this guy right here. He's 6 rad 3. That's the height. You just found the height of this guy. That's what it asked you to do. It's asked you to find the height. It's looking for this guy right here, 6 rad 3. That was the goal. All right. Oh, why is this person on again? Go away. All right. Review. These are review questions. Your review questions, there's a rhombus question. There is a triangle congruency, and there is a proportion problem, which I totally screwed up on this review sheet, so we'll probably just skip that. All right. Here we go. ABCD is a rhombus, okay? Rhombus, you got to know all sides are congruent. All right? All these guys are congruent. You also have to know what happens inside the rhombus. All right, inside the rhombus, you've got perpendicular bisectors, meaning that they create right angles in here. Okay, all these guys in here are right angles. All these lines are parallel, so you're going to have alternate interior angles. You're going to have diagonal bisectors. If this guy's 41, this guy's 41. Okay? This guy in here is 90. So at first they ask, what is BEC? BEC, 90 degrees. Okay? You got to know who that is. Okay? You got to know that this guy right here, inside a rhombus, is always going to be 90 degrees. So he's 90 degrees. CBE. I see a lot of issues with you guys naming angles. We're looking for CBE. CBE. That's this angle right in here. All right? That angle right there. Here, we've got a triangle. Let me just draw this guy out a little bit so you can see him. All right, we've got E, C, and B. This guy's 41. This guy's 90. How do I find this? It's 180 degrees. So this total needs to be 180 somehow. So let's do 90 plus 41, 136. All right, 180 minus 136 is 44. This guy right here is 44. So they asked you CBE is 44. And then they want DAE. DAE, that's this guy right here. Alternate interior angles are congruent. This guy is going to be 41. Okay. Review from last exam. Triangle congruency right here. This guy's marked. This is angle, side, angle. Angle, side, angle. So this guy right here, angle, side, angle. All right. This one right here, totally screwed that one up. Sorry, guys. But there is a proportion question on there. So it would look like if you needed this, I gave you the answer because you're supposed to have like a X on one of these. So sorry about that. I gave you all the answers. But basically, you're looking at doubling it. So this guy's double this. This guy's double this. Okay? You got the little piece and the big piece. So there is a proportion. You're just going to have to set it up. You can go little over little, big over big. You can do each proportion over the other. Okay? They're all good. It just depends on what they're looking for. So this is your proportion one. All right. Questions. Did you want me to do any more of these? 30, 60, 90 triangles. So I'm going to do some more of these. I think you guys didn't like those questions. Okay, let me do a $30-60-90s. Okay, so are you good right here that 30-60-90 is not one of these problems? Okay, none of these problems. This is not a 30-60-90. This guy right here is going to be a 45-45-90. Okay, so 45, 45, because these are isosceles. This guy right here is the same thing. It's going to be, they're marking here, they're isosceles. You got this one's here. Okay, 30-60-90. Let's try here. These are the ones you wanted. So let's do this. All right, opposite the 30. So here, let's go again. Opposite the 30 is x. Opposite the 60 is x rad 3. And opposite the 90 is 2x. All right, so we're just going to plug it in. Opposite the 30 is 5. It's given. All right, so opposite the 30 is 5. Opposite the 60, all right, which would be this one. We know what x is. X is 5, so it's going to be 5 rad 3. Why is it like that? That's just the rule for a 30-60-90 triangle. Okay? Why is this like that? This is the rule for a 30-60-90 triangle. Anytime you have a 30, 60, 90 triangle, your hypotenuse is double this and is double the short side. And opposite the 60 is always the short side rad 3. Okay? It's going to work like that consistently. So then we've got this guy right here is 2 times 5. So opposite the 90 is going to be 10. Right? So this is what I'm saying. You got to memorize this part. All right? If you remember it like this, opposite the 30 is your x. Opposite the 60 is x rad 3. Opposite the 90 is 2x. So let's do here. Okay? Let's take our same thing. Opposite the 30 is x. Opposite the 60 is x rad 3. Opposite the 90 is 2x. Right? I'm given this. All right? I'm given this. So this is 20. If this 2 times the short side, I know this is half of it. It's 10. Okay? So this guy right here is 10. So your little side right here is 10. This guy right here is 10 rad 3. Opposite the 60 is just 10 rad 3. Okay? All right. These ones right here, way easier, 45, 45, 90. We've got 2, 2, 2 rad 2. That's it. If this guy is 6 rad 2, then this is 6 and 6. 6, 6, 6 rad 2. Super easy. Okay. Any other questions? You guys good? Do you want me to do anything else? Go over any other problems? I think you guys are good on radicals. Let me know. No? Okay. So tomorrow your exam. Remember, whoever your teacher is can you say what's going to be on the test? Yeah, absolutely. So on the test, you are given, you're going to have to do, zoom out a little bit. All right, there we go. You're going to have to determine, is it a right triangle? Okay. And I think there are like 4 of those. All right. You have 45, 45, 90 triangles. You have 30, 30, 60, 90 triangles. And I think there are 3 or 4 of those. You're going to have Pythagorean theorem. So a squared plus b squared equals c squared. You're going to have triangles like that where you need to find a side or find the hypotenuse. I think there are a couple of those. There is the review is going to be triangle congruency. So what is it? Like angle, 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 or not angle, 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 side, angle, 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 side, those kind of things. So triangle congruency, there is a question on your test, it's on a rhombus. So there's those questions. And then there is this the proportion problem. All right. So those are your 3 review questions. There are simplifying radicals. All right, simplifying radicals. So that is, I think there are 3 questions, 3 to 4 on those as well. And that's it. There's a word problem, which I'm not sure if every teacher is going to have everyone do. It's basically just, everything's going to be right triangles. Okay, so all of this, at the end of the day, everything is right triangles. Okay. And there is one with a graph. I can kind of show you what it would look like. So if you're given a graph, they're going to ask you to find the distance between 2 points. Okay. So they're just going to say, find the distance between this point and this point. Find the distance. And the way you find the distance, the easiest way to find the distance is to just create right triangles. Okay? When you do this, if you guys see, you just count the units. So this one's 2, this one's 3, Pythagorean theorem. Okay, 2 squared plus 3 squared equals, there's your hypotenuse. All right, here we go. 4 plus 9 equals c squared. 13 equals c squared. Take the square root of both sides. C equals rad 13. Okay? All right. So there is a question like that, but again, when you get the graph, draw a triangle on it. All you're doing is using the Pythagorean theorem again. All right, I'll see you guys tomorrow. Again, if there's stuff that I went over that your teachers didn't teach you, not a big deal. The tests have been modified because I know that we were short a day because of the fires. Good luck, and I'll see you guys. Yes, there is school tomorrow. All right, I'll see you guys tomorrow.